So, hi Barry, hi Ian.
Hi.
Hi, Isha.
Yeah, so welcome to the podcast. This podcast is for those who don't know anything about osmium and would love to learn. So, it's lovely to connect with you both today. So, let's start with your introductions. So, Dr. Barry, we can start with you.
So my name is Dr. Barry Creighton. I started as a podiatrist and I ended up getting into medical devices manufacturing. So we basically created our own manufacturing plant here in the United States and created it, built it from nothing into an international company. And then I exited about a decade later, about 2 decades of my life. And then I worked for a multi-billion-dollar company that bought us out for a few years until they sold. And since then, I've been in the startup ecosystems here locally and involved in real estate as well. And you can call me Barry. That's fine.
Yeah, okay. Yeah, so what about you, Ian? How did you get into this?
I started a precious metals business in summer 2020 and started attending different conferences to learn more, reach more public, grow the business. And at the New Orleans Investment Conference, we were exhibiting selling precious metals. And a few booths along was the Osmium Institute. It was their second foray into the US. They had made a brief attempt before COVID, then COVID came in and sort of knocked that flat, the travel, etc. I was skeptical because it was shiny and expensive. But when I learned about its fundamental properties and its appearance, I was convinced I needed some of this osmium.
So, let's talk about what diamond sparkling crystalline osmium is exactly.
So diamond sparkle crystalline osmium. I'll let Ian go with this because he's senior in this and knows more about it than I do.
Yeah, with
Sure.
your experience in the gem industry, I think you can talk about it.
Okay, so osmium is the 8th precious metal. In its raw, refined form, it oxidizes readily and it's toxic. So it hasn't been suitable for the retail precious metals investor. About 52 years ago, a Swiss scientist set on a journey, which probably ended up a lot longer than he thought, to take this raw osmium and turn it into a crystalline form. So you could compare the process as similarities to creating diamonds, except that he was turning the rarest element and a precious metal into a beautiful, more than durable form. In its crystalline form, it's the only element or compound. There is no element or compound that cannot be dissolved in an acid or alkali. So he created a crystalline form of the osmium, which is completely inert, incredibly safe, but also stunningly beautiful, almost as close to 100% reflective as I think we're ever going to make anything. And because of its reflectivity and because it reflects parallel light, because of its crystalline structure, it really performs in sunlight or in white LED lighting.
Okay, so can you explain how is diamond sparkling crystalline osmium is different from the other forms of osmium?
Yeah, in the crystalline form, it's completely inert, completely safe. It's in the densest form you can get osmium. So in the raw form, it's a powder, or sometimes some people sell it in sintered beads or sintered cubes. Technically and practically, that still will oxidize because it will have nanohole particles in it, which will allow oxygen in the air. And you can see if you put some of these products on paper and leave them for a few days, you will see a brown stain starts to appear. That's the evidence of the osmium tetraoxide compound forming. And osmium tetraoxide will attack and destroy eye tissue and lung tissue. But to be clear, in the crystalline form, it is the most inert anything. There is nothing as stable.
Okay. So if we talk about the history of osmium, where did osmium come from and where is it going in future? So I think, Barry, if you can talk about how you were connected with the institute and how is it going in the future?
So yeah, actually, I was interested in precious metals. I'm actually traveling in Jackson Hole, Wyoming, a few summers ago with my family. My son wanted to go see Jackson Hole, and he wanted to see the big park there. And so came into his shop and met him, and he had these crystals he was showing to me and going on about it. And so I thought it was pretty cool. Actually, what he's saying made sense to me, and I was interested enough that I bought some. And then later he invited me to try to help him with the business. And I'm started in the startup ecosystem, and what he was telling me made sense to me.
There's a reason why there are a few industrial use of it. So what is that?
Let me start with something.
Yeah.
Right. There's about in volume 2 of these that will be turned into diamond sparkle crystalline osmium.
Yeah.
Okay. So in the world, right, they can estimate they can mine between 1 to 2 cubic meters of it. So you can fit that in the back of a pickup truck. So I have patents, I've developed products, and I can tell you, you'd be insane to try to spend hundreds of millions of dollars developing a product and then not be able to get it, right? Or you would use it up so fast that the price would escalate so rapidly that you would put yourself out of business. So no one in their right mind is going to develop an industrial use for something that is so rare, right? And that's what attracted this initial Swiss scientist to it, because he realized how rare it was and it could be used. But that being said, there is an industrial use for it now.
So you mentioned that it's rare, but how rare?
Okay, so if you were to compare this, so if you would take all the mined gold in the world and stack it, you would get about a 5-story tall building, tall and wide, right? So I just compared that to how much osmium there is. So it's about 700,000. I've calculated about 700,000 times more rare than above ground gold, the diamond sparkle crystalline osmium version of osmium.
Yeah.
So it's exceedingly rare. It's even more rare than diamonds. Typically, now that diamonds can be manufactured. And diamonds are still beautiful, but this also is far and exceedingly more rare. And so anytime it has something far more rare and the demand for it increases, the chance for it to go up increases rapidly, right? That's what the story is behind some of the cryptos, right? Like Bitcoin, because it's so rare.
Yeah. So many sophisticated investors wants to know about it more, and how there are any industrial use of it and how they can get into it to use.
So osmium in the raw form does have a few uses. I'll rewind right back to when it was first isolated. So it was experimented with, and it was used with tungsten as light bulb filaments because of its incredible high melting point. But they realized even then there's no point continuing this because they weren't able to source any, they'd maybe make a few hundred light bulbs and then they'd have to wait another year to get some more osmium. So way back when it was originally isolated, they realized this is not suitable. It does have some scientific research uses. It has been used for making mirrors for space applications. It is also used in very, very low concentrations. It's added to gold. It makes gold in 24 karat gold much more durable and scratch resistant. But these are in tiny, tiny concentrations. So what we have in the crystalline form, it's the rarest form of the rarest element, which happens to be the 8th and final precious metal to be brought to the market. So that's a fascinating proposition. And in this crystalline form, it's a crossover. It's a precious metal, but it behaves and it looks like an incredible sparkly gem. And it has applications. So if you call jewelry an industry, that is its industrial use. It's in fine watches and fine jewelry.
When you talk to a lot of investors, they understand that they are going to ask, okay, so what's its industrial use? And the reason they ask that is because there's a lot of metals out there that are far more rare than gold, that they're worth less and they're not going anything in value. Take, for example, platinum is about 10 times more rare than gold, but it's about a third the price right now, and ruthenium and there's others. And so what the difference is, and what's not understood by them that we're trying to explain and clarify is, so yes, you have something that says is very rare, right? And so the price is low, and so you have a price here, right? So you have the rarity and the price. You're talking hundreds of tons that may be mined per year of this. So yeah, it's rare, but there's not a lot of use for it, so the price stays low. This stuff, it's ultra, ultra, ultra rare, right?
Yeah.
Just a little bit of spike in this really will dramatically increase the price. I mean, again, we're coming back to there's literally about 2 of these. So how much demand for this before the price sparks. It's not a huge quantity. It's a very small quantity. We talk about squeezing stock prices higher. We talk about squeezing, the precious metal higher. This is the easiest squeeze of all time, right?
Yeah.
I mean, it's starting to take off in jewelry now. Ian has a watch made by a luxury jewelry brand that comes out of Europe, and it made its way into the cover of the jewelry magazine of Britain last year. And this year, it was $1 million set of jewelry, crystalline osmium jewelry worn by one of the goers at the Brazilian carnival this year. So, and now it's making its way into the United States. So it doesn't take a lot of demand for this stuff to go. And that's what they don't understand. They're thinking in terms of hundreds of tons, so they're not. There's none. And it's not
I mean, by weight, there's 350 kilos will be made in a crystalline form.
Like this is all ever that will be done per year.
And that, as Barry said, that works out pretty well exactly to 2.5 basketballs or a cube with a 10-inch dimension, so a 10 by 10 by 10-inch cube.
You can put all into a treasure chest, all the mined osmium discs into a treasure chest, and that would be the most valuable treasure chest on the face of the planet.
So the crystalline form is just the 2 basketballs.
Yeah, 2.5 would be 2.5 if it was completely packed in tight with no spaces.
Right.
So it's not a lot of product. I mean, I don't know if the light will catch it. There's it
does. It's beautiful.
Crystalline osmium watch place. You really need to see it in sunlight to really catch the dramatic sparkle. It's the only precious metal that has beautiful blues in that reflection. And again, I mentioned earlier, that's due to the crystal structure. It's a hexagonal crystal structure. And the faces of those mirrors are parallel to the plane, so they reflect parallel light straight back at the viewer. And if you hold a diamond in natural sunlight and a piece of osmium the same size, it makes a diamond look very, very plain and boring.
Oh, so the sparkle is that much?
Yes. Yeah, and you can see it for a greater distance, about 3 times the distance, a similar sized piece of osmium to a similar sized diamond in daylight. If you can see the diamond at 10 feet, you'll be able to you'll see the sparkly osmium at 30 feet.
Oh. So could you say that the diamond sparkle in crystalline osmium is something we can compare to Bitcoin or crypto in terms of investment purposes?
Except except there's a lot of Bitcoin. And what's it trading at? Around $80,000, and there's going to be 20,000 of them. There's a lot of Bitcoin. The crystalline osmium market is so small compared to the Bitcoin market. What will happen is just a handful of people will invest in this and get the gain. This is not a hard sell. Not many people will be able to buy this. What we have found when we put pieces on display, people are attracted to its appearance, and sometimes they buy it just because of its outstanding sparkle. Add to that all of the features, the scarcity, the story, the 40 years one scientist dedicated to creating the process. It is an incredible, fascinating story.
And it's not just this 40 years. There's 160 steps to do this.
The process is 160 conditional steps. If any one of those steps is not fulfilled, the whole process fails. And you're talking of boiling. The osmium has to be boiled. After it's cleaned to an atomic level to get it, but I think between 9 nines fine and 11 nines fine. So that's 299.79s pure, because the slightest impurity will mess up the crystallization process and you won't get an even crystallization. And then it is boiled, so it's taken to over 9,000 Fahrenheit. So I think that's similar to the temperature of the face of the sun. And all this has to be done in an environment where you can't have contamination as well.
There are other forms of osmium, right? But the cost to create this stuff from an industrial standpoint is so much higher that, some people will say, well, the regular osmium is less expensive. Well, I'll say, yeah, but, a Ford Fiesta is cheaper than a Ferrari.
and you won't get a fine Swiss watch manufacturer will only use the Osmium Institute's crystalline osmium because it's the only company that's managed to get to this level of uniformity of height of crystal structure.
We call that quality.
Yeah. So I would say this is amazing to learn so much about osmium from you two. But I think I still have a lot of questions around the topic, and it would be lovely if we can connect for another podcast where we cover some other questions about what osmium offers in the future and what's the future of osmium and the jewelry in the coming years.
Yeah, it'd be great.
Yeah.
Yeah, thank you.